Hey everyone, welcome. Today, we're going to dive into a topic that can be a real head-scratcher in Kubernetes. How to run those apps that actually need to remember things, like databases. Your standard tools can kind of fall flat here, but luckily, there's a really powerful solution called a stateful set. So let's break down exactly what it is and why it's so important.
All right, so to kick things off, let's set the scene. Kubernetes is an absolute champion at managing what we call stateless applications. Think of web servers, where it doesn't matter which copy of your app handles a request. But stateful applications, the ones that need to hold on to data and keep a stable identity, well, that's a whole different ballgame.
So what's the big deal here? Why is it so hard? Well, it really comes down to a fundamental conflict. Containers, by their very nature, are designed to be temporary, disposable, interchangeable. But databases are the complete opposite. They need stability, their data has to stick around, and they need a name that doesn't change. So how on earth do you get these two opposing ideas to work together?
There's a classic analogy that explains this perfectly: pets versus cattle. When you use a standard Kubernetes deployment, it treats your application pods like cattle. They're all the same, they're interchangeable, and if one goes down, Kubernetes just spins up a new, identical one to take its place. Super efficient and absolutely perfect for stateless apps.
But here's the thing, a database is not just another cow in the herd, it's a pet. It has a unique name, a specific job, and it holds your critical, irreplaceable data. You don't just replace your pet if it gets sick, you take care of it. And that's exactly where a standard deployment just doesn't cut it.
And this right here is where the hero of our story comes in, the stateful set. The Kubernetes team knew this was a problem, so they designed this specialized controller specifically to manage these pet applications, giving them the special treatment they absolutely need to run reliably.
Okay, so what exactly is a stateful set? Think of it like a deployment, but with some very important non-negotiable rules. The big difference is that it provides rock-solid guarantees about the ordering and uniqueness of its pods. A deployment says all pods are the same, but a stateful set says, nope, each pod here is special and has an identity that sticks with it no matter what.
All right, let's get into the good stuff. To really understand what makes a stateful set so powerful, we need to look at what I like to call its 3 core superpowers. These are the features that let it handle even the trickiest stateful apps.
Superpower number 1 is a stable, unique network identity. Now, with a normal deployment, if a pod dies, its replacement gets a totally new random name and IP address. It's anonymous. But with a stateful set, that's not the case. Each pod gets a persistent identity that it keeps for life.
And here's how it works. It's actually pretty straightforward. Each pod is given a predictable host name. It's just the name of the stateful set followed by a dash and a number, starting from 0. So if your stateful set is called Web, you'll get pods named Web 0, Web 1, Web 2, and so on. And that name, that identity, follows the pod everywhere, even if it gets moved to a completely different server.
Okay, but you might be wondering, how does this naming magic actually work? It doesn't just happen on its own. It needs a very specific partner, a helper object, working right alongside the stateful set. The secret sauce here is something called a headless service. Now, a normal service gives you one single IP address to balance traffic across all your pods. A headless service, well, it doesn't do that. It has no IP of its own. Instead, it acts like a DNS phone book for your pods, creating a unique DLS record for every single one of them. That's what provides the stable, findable network identity.
On to superpower number 2. This one tackles the other big piece of the stateful puzzle, the actual data. I mean, a stable name is great, but it's pretty useless if your pod just loses all its data every time it restarts, right?
And this is where persistent volumes come in. Every single pod in a stateful set gets its very own dedicated piece of storage through a persistent volume claim, or PVC. This creates a direct link between the pod's identity and its data. So as you see here, the pod Redis 0 will always connect to its specific storage volume, Redis data Redis 0. The data literally follows the pod's identity, making sure it always reconnects to its own stuff.
And finally, we have the third superpower, and this one is absolutely critical for any kind of clustered application: ordered operations. Stateful sets manage their pods in a very careful, predictable, and orderly way. There's no randomness here at all.
So check this out. When you scale up a stateful set, the pods are created one by one, in order.
pod 1 won't even begin to start until pod 0 is completely up and ready. And when you scale down, it happens in the exact reverse order. This predictable, graceful process is a lifesaver for things like database clusters, where the nodes depend on each other and have to be started and stopped in a very specific sequence.
Okay, now that we've seen all the cool things a stateful set can do, let's put it side by side with a standard deployment. This should make the differences crystal clear and help you know exactly when you need one versus the other.
This table really says it all. For pod identity, deployments are cattle, stateful sets are pets. Simple. For storage, deployments usually get shared or temporary storage, while stateful sets give each pod its own dedicated permanent home for data. And for ordering, deployments are chaotic and random, while stateful sets are completely predictable. It's easy to see how this leads to their ideal use cases: deployments for your stateless web apps and stateful sets for your precious stateful ones.
So what does this mean for you when you're building things? When should you actually reach for a stateful set? Well, it all comes down to what your application really needs.
You're going to want to use the stateful set for your databases. Postgres, Cassandra, you name it. For message queues like Kafka. For distributed caches. Basically, if your application has instances that need a stable network name, their own chunk of persistent data, and need to be scaled up or down in the specific order, then a stateful set is without a doubt the tool for the job.
All right, before we wrap this up, I want to go over the most important takeaways and give you a couple of pro tips that, trust me, will save you a massive headache down the line.
Okay, really listen to these. First, you must have a headless service. No ifs, ands, or buts. It's required for the DNS to work. Second, always scale your stateful set down to 0 replicas before you delete it. This makes sure everything shuts down cleanly. And third, and this is the big one, deleting the stateful set does not delete its storage. This is a safety feature to stop you from accidentally deleting your data, but it means you are responsible for going in and cleaning up those persistent volumes yourself. Don't forget.
And that brings us to a final thought. Stateful sets are the fundamental building blocks, for sure. But the whole ecosystem is moving so fast with amazing tools like Kubernetes operators that automate even more of this heavy lifting. So the question I want to leave you with is this: what's next? What's the next frontier for running these complex stateful applications on Kubernetes? Thanks for joining me.